Hi, hello everyone. Fabulous 6. Let's do it. Find the number of distinct colors among the balls. Given an integer limit and a 2D array queries of size n times 2. What's n? There are limit plus 1 balls with distinct labels in the range 0 to limit. Initially, all balls are uncolored. For every query, in queries that is of the form xy, you mark ball x with the color y. After each query, you need to find the number of distinct colors among the balls. Return an array result of length n, where result I denotes the number of distinct colors. Well, I mean, it's color, but essentially just telling you you will mark a ball, you just get a number to the ball, or get a number to that value. And so, okay, so initially this one we have 4 positions, right? 1, 2, 3, 4. And I think 1, 4 is ball 1, 0, 1, 2, 3. Yep. So basically, in the first iteration, I have, would the color be, so this is the position, this is the number. So I can set everybody to 0 at the beginning, right? So that's the beginning. And the first step is going to be 0, 1, no, 0, 4, 0, 0. Which is 1. Second step is 0, 4. We change this to 5. So that'll be 2. And then this change into 3. And then this change to 4. So basically each run you need to find out the number of uniques. A number of uniques. The number of uniques. So what if I just keep track of the uniques? Let's say I have unique 4 at position 1. And then we have 5 at position 2. And then we have 3 at position 1. 3 at position 1. How do you know? 3 at a position 1. 3 at a position 1. So you go to position 1, you change it to, so basically you need to remove it first. And then set it. So it's like we have a group of uncolored ones, okay? And each time I have a query, okay? So we check if it's inside. So we say, okay, it's inside, so I take it out, I put it into the colored group, okay? I put it in the colored group, so I put it into the colored group, okay? And I also have unique colors. So essentially we have color. So I need a color and I need the mapping on the, because we have 0, 1, 2, 3. Let's say initially this is 4. And then I put 4 in. and I have a counter 4. Counter is 1. Next I put a 5 to 2. So I put a 5 as 1. Next we say 1 is 3. So this is 3. So 4 minus 1 becomes 0, so I remove it. And then 3 become 1. Right? And then we have this one's 4. Then 4 doesn't exist, we put 4 in it. That shall be it, right? And then we just keep tracking of this, all right? I think this shall work. And in fact, I don't need, let's see, 10 to the 9th. So the color definitely needs to be a map. Oh, the limit, I have to be a map as well. No, limit is, yeah, limit has to be a map as well. All right, so everybody has to be a map. Not that bad. All right, let's do this. So we have a map of int. We say ball to color, right? Ball color. I need map. What else? Color count. Okay, so I have this, and we also need a vector of int res. So 4 limit. What does limit do? Why do I need a limit? Limit doesn't do jack, right? Limit doesn't do jack, so I don't need a limit. I just need a query. So auto queue of queries, right? So we say index is q0, and what else? Color is q1. All right, so what I do is I'll check if ball color index, let's call it ball. I think it'll be easier for you to understand. So this, if this ball is equal to 0, which means that's a fresh one, and then we say ball color, ball will equal to color, and we say color count ball plus plus, right? So that's it. No, color count is color plus plus. Else, then we say color count old color, right? Old color is ball color ball, and then ball color ball will equal to new color. And actually, let's do this first. Color count old color minus minus, and if not color count old color, then we say color count dot erase old color, and then handle that. So we do this, and then we do color count color. Oh, I just realized we repeat the same code. So I can just say if this, right? Don't do this, don't need to do this, and I do these here, right? So if we don't have a color, if we have a color, we get the old color, we do the color count, and then we remove it, right? And then we do this, and then we say res dot pushback color count dot size. and to return res. Alright, I believe this shall work. This is 3160. Use two hash maps. One keeps count. Right? One keeps a record of the ball's current color, while the other, the number of balls with each specific color. At each query, we update the ball's color and update the color counter as well. The answer to each query is the if a color has no ball associated with it, it will be removed from the counter. The answer to each query is the size of the counter at the moment. Okay, let's run, and if it looks good, then we'll submit and call it a day, because I still have to train. It's kind of, you're pushing the training back more and more every day, which is okay, you know. It's never ideal, but yeah, it's all right. 292, 10%. I wonder what was the a better solution for this. Take a look. Hash map an array. What do you mean by array? Got a result. I wonder if unordered map make it faster. Color map and ball array. They use a ball array to do this. I guess that make it faster. That I do not know. Maybe. 2 hash maps. Okay, let's try. Let's try unordered map. Unordered map. Okay, so we say update 1. Use unordered map to see if performance will improve. Would improve. So again, we try this one first. Looks good. Because unordered is yes. It improved tremendously. So update 2, use array to replace one of the unordered map. To replace the unordered map for ball color. So we say std vector of int ball color of size limit +1 set to 0. Okay, everything else I think is the same. Yep, it's the same. How much do we get? Memory cannot do it this way. So yeah, this second one doesn't work. So we have to go. Yeah, that's what I thought. Right, that's what I thought. Unless it does the array differently. How does it array? It does a vector, right? It does a vector, which means it's exactly the same, and it will memory. Yeah. So this is not gonna work, but this is working. All right, I actually let me copy this. Yep, I'm gonna copy this. count this as solution 2. Right? This one scores 175 millisecond or 34%. So remember, an order map is faster than this. All right, that will be it. 15 minutes, not too shabby, right? I'll see you guys tomorrow. Adios.